So I ended up doing the more professional intro, and I didn't realize that this was such a fun group, so I will say that we are also a cat group, because someone beforehand said that they were supervised by cats. And I have 4, Kathleen has 2, we now have 15 in my research group. If anyone here is looking for graduate school and has a dog, please come and even us out. Or any other animal. I once had someone with a bird. I don't want to be too speciest. So we're back on PFAS, and Joe gave such a great presentation for DEQ. We were trying to kind of anticipate what you'd know about PFAS going in, so I'll just start out by saying that we've heard a lot about this forever chemical at the national level. It's definitely an issue in Virginia. You might have noticed some of the talk we mentioned about the sampling around Roanoke and the Chemours spill. There's all the issues over on the Eastern Shore. Lots of concern about PFAS. It haunts our dreams and nightmares. So I'm going to be talking about not surface water, but drinking water, and specifically drinking water in private systems. I'm going to give you some of the background. This was Kathleen's master's research, so she'll talk about the actual results, and then I'll come back to kind of contextualize. But we're not talking about community water systems. I know there was a question about which water systems have or have not sampled. We're talking about private systems. So these are wells, springs, and cisterns. And depending on how you quantify it, there's actually a fair amount of debate. About 10 to 20% of Americans do rely on these systems. The big deal is that they are not subject to the US Safe Drinking Water Act. That means that all monitoring and maintenance falls directly on the homeowner. And as a homeowner myself, I will say that maintaining anything on the in your home is a challenge. Treatment prior to consumption is limited. My group has done a lot of work on private drinking water systems. We found very high levels of fecal indicator bacteria just at ambient levels. About 1 in 5 homes has high lead. Not a lot of homes rely on treatment. A fair amount on what we would say is conditioning, so things like water softeners, but not a lot of like UV treatment or activated carbon reverse osmosis. And when it comes to PFAS, there has been some work on PFAS in private drinking water systems related to kind of disasters. So if you think about what happened with DuPont up in Ohio and West Virginia, there's that Mark Ruffalo movie. After disasters, we tend to do a lot of sampling. But PFAS is indeed everywhere. Unfortunately, I don't mean to be a horror show early in the morning, but I'm sure you've all come into contact with PFAS this morning. It's in cosmetics, it's in personal care products, any kind of weatherproofed or synthetic material. There's been very little research on PFAS in private drinking water supplies at baseline, so not after disaster. And since it is so ubiquitous, and we just talked about septics, we know that septics frequently, if you don't have the best drain field, then that can end up in your private water supply. We don't know a lot about how much PFAS is just there on the day-to-day. There was recently a great USGS study. It did include some private well samples, but only 5 from Virginia, but they found about 20% of samples had detectable PFAS. So we're lucky enough that here at Virginia Tech, we have the Virginia Household Water Quality Program run by Erin Leigh, who is a senior extension associate. This provides low-cost water quality testing and education and outreach to over 3,000 Virginian households every year. They're in almost every county. Again, they're saying that maybe 1 in 5 Virginians are relying on a private system. Typically, they're providing sampling for fecal indicator bacteria, some standard metals, and other standard measures. So Erin has presented many a time here at the Virginia Water Monitoring Conference. Knowing and having had past experience working on things like lead and indicator bacteria with Erin, there was a call from USGS a few years ago talking about asking for information on PFAS. And we decided to partner, and luckily we did get funded, to look at private water supplies and patterns of PFAS exposure. And our motivation was twofold: that drinking water is hypothesized to be the primary vehicle for PFAS uptake in humans. Over 90% of humans all over the globe have detectable PFAS in their blood. And as I said, it's in about everything, but we hypothesize that water's the main way that we intake it. Private water supplies may be uniquely vulnerable. No one has to test them. If you don't have a lot of treatment prior to consumption, anything in the groundwater ends up at the point of use. So, before I let Kathleen tell you about what exactly we did and found, there was a great question. I feel like we are exactly on the same wavelength about regulations. So a big part of this cooperative extension program is providing information to the homeowner. If it's your private system, you have to make your own decisions. That is very challenging. I want you to keep this in the back of your mind in the face of these regulations. So when we applied for this grant and were awarded, US EPA had a recommendation, this was non-pending, right, that the sum of just 2 PFAS compounds, and remember there are thousands of species, we typically test for between 2 and 3 dozen in drinking water, that the sum of PFOS and PFOA be less than 70 parts per trillion. Okay. Then we start planning for our phase 1 sampling. And now US EPA comes out with these health advisories, and I just want everyone to take a moment and look at these units. We're talking thousandths of parts per trillion. So that's parts per quadrillion. That is unbelievably small and also, frankly, not something we can test down to that level of detection. But we had health advisories for 4 different compounds, right? So we did our phase 1 sampling. We finished our phase 1 sampling. I'll just call out Kathleen here, hands in her thesis on her birthday, says, I'm ready to defend in a month. And then on that very day, EPA was like, guess what? We're changing the MCLs. New MCLs, we're proposing less than 4 parts per trillion for PFOS and PFAS. The MCLG, the goal is 0 detection. And then they're proposing this hazard index for a series of 4 long and short chain PFAS. Now we're doing our phase 2. These are proposed. These are not final maximum contaminant levels. There could still be some further development. And the Safe Drinking Water Act does not apply to private systems. So just keep this in mind as we talk about how we're going to educate people on what to do if we find PFAS. And now I'm going to let Kathleen actually tell you about the magic we did.
Okay. Thanks so much, Leanne. And yeah, that was the worst birthday gift probably ever. I did have to rewrite that for my paper, which was not fun.
We let her do it after the defense.
Yeah, I still passed. Thank you.
Yeah.
Okay, so thanks for that introduction. I'm going to go ahead and talk a little bit about what we did specifically for this phase 1 of the USGS project. So initially we had this, it written into the grant that we'd have kind of a pilot study. And for this pilot study, we had 2 major questions when it came to quantifying PFAS in private drinking water. The first is whether or not we'd find PFAS at all. Would PFAS be detected in private wells or at the tap? And we call that the point of use. So anywhere where you get your drinking water from when you go into your kitchen or wherever, most of the time that's like a kitchen sink. And so we were also interested in well groundwater to see if PFAS was there. And also, I think the last presentation kind of alluded to how difficult it can be to sample for PFAS. There are some really strict regulations about and rules about how, the right clothes that you have to wear, certain things you can't have in and around the sampling area while you're collecting. And that's due to the fact that PFAS is virtually ubiquitous in consumer and industrial products, which makes things really difficult. So I'll talk a little more about some of those rules that we had to follow for sampling. But because we're partnering with the Virginia Household Water Quality Program, this would allow homeowners or participants to collect their own PFAS samples for analysis. Other studies had done this in the past, and we were interested in whether or not these homeowner samples introduced any bias because they weren't following such strict guidelines for sampling like the experts were. So I'm going to talk a little bit about our study design here. So we started in Floyd and Roanoke counties. We chose these 2 counties based on proximity to Virginia Tech, as well as they had these risk assessments done by the Virginia Department of Health. And so Floyd was considered a low-risk county, and Roanoke was considered a higher-risk county, which I can talk more about later. But then Experts went in, so me and some other graduate students and undergrads went and sampled 20 homes, so 10 in each county, and we collected one PFAS sample inside the home at the point of use. So this would be, like I said, your kitchen tap or wherever you get your drinking water from. And then we also collected a sample outside the home, so this would be from a well spigot or somewhere where water does not interact with the inside like plumbing of the home. So we wanted to see if those would be if we'd see any difference there. And then we also worked with homeowners. So once we went to these homes, we gave people these drinking water kits. So you can see some of these bags and bottles. Homeowners collected only from the inside at the point of use. And so they collected the first PFAS sample as well as a second PFAS sample kind of at the end. And in between all of that, they collected a Virginia household water quality sampling kit, because ultimately, although we're interested in PFAS as an emerging contaminant, we're still interested in giving homeowners that information about their general drinking water quality that, we know for a fact does affect their health, including things like fecal indicator bacteria and lead. They also answered a bunch of surveys, and they also collected some pH and conductivity samples. So this is a little bit of some of the results that we found. We found at least one PFAS detected in 88% of point-of-use samples. So we had about 60 total of those samples, and we found about at least one PFAS species in at least 88% of them. The average sum PFAS concentration in a point-of-use sample was about 23.5 parts per trillion, with a maximum of 160. I believe the outside sample max was about 250 parts per trillion. So that was significant. We detected quite a fair amount of those short chain replacement PFAS. So we talked earlier about short and long chain, and so these are some of those replacement PFAS. But none of them exceeded the EPA health advisory limit of 2,000 parts per trillion, which is good. And so obviously no samples from anyone's home at the point of use exceeded the health index that was proposed by the US EPA, which is also positive. We only had 2 homes in Roanoke County exceed the proposed MCL for PFOA, which was 4 parts per trillion. And the same 2 homes and another, so 3 in total, exceeded for PFOS, and 0 exceeded for the MCL in Floyd County. So ultimately what we're looking at here is a lot of below the limit detections, which is kind of like an ambient background PFAS, but they would not, should they have been regulated by the Safe Drinking Water Act, they would not be in violation. So another thing that we found really interesting is we talked a lot about mixtures. And so this, obviously with the health index being proposed by the EPA, more than one PFAS detected in a single sample can be indicative of increased health effects, and they're really not well studied in combined mixture. So the average number of PFAS compounds we found in a point-of-use sample was 3.3, so about 3 unique compounds per sample were detected, and outside was a little bit more at 3.4. So 66% of samples, so of all the samples we collected, both inside and outside, contained more than or equal to 3 specific PFAS compounds. So it's indicative that there's quite an interesting group of chemicals that are all being detected at the same time. And so obviously the maximum number of PFAS compounds was detected in a single sample was 8. And so I mentioned a sample earlier that was outside that was about 250 parts per trillion, and that was the sample that had 8 different compounds. So another thing we were kind of interested in exploring here was whether or not concentrations or detections of PFAS compounds are related to one another. So this is a Spearman's correlation coefficient matrix. So basically, that just means that these numbers and the colors associated with them, the closer to 1 and the closer to blue it is, it means like the higher, that higher concentrations are correlated to one another. So if you have a high concentration of one thing, you'd have a higher concentration of another. And so some of these are the PFAS that we generally detected in private wells. And so we ultimately determined that there was a variety of legacy PFAS that were frequently detected with their short chain counterparts. This can be a result of some degradation that can occur in the environment. And then also, we didn't find any super strong correlations, obviously because we only had about 60 or so samples. However, high concentrations of PFHXA and PFBS were indicative of overall higher some PFAS values, which kind of makes sense because we had a lot of detections of those. I think I mentioned that earlier, that like 60% of samples contained PFBS, so that kind of makes sense. And then also legacy PFOS, which is one of those PFAS that we don't make in the United States anymore, is correlated to other long-chain PFAS like PFOA and PFHXS, which is another PFAS that we're like interested in regulating. And so ultimately, we came to a couple conclusions here. But there's still more, like any good research project, you come to the end of it and you have more questions than you started with. Ultimately, PFAS detection in Virginia private wells is common, but it's really variable. As you could see from that graph, the homeowner and expert samples covered a wide variety or wide range of concentrations and detections. So also the detection of PFAS compounds in mixture was also common. So we're also seeing the need for more research to indicate, what kind of health effects we can expect or how the US EPA can better regulate mixtures in PFAS, in drinking water samples. And also that a variety of compounds were detected, so both legacy and replacement. So some of those long chain ones that we talked about removing earlier and that are out of production in the US, we're still seeing those show up in drinking water samples. And so out of the 31 that we could measure for, we found 15 of them. And ultimately, we found that homeowner and expert collected samples did show inconsistent bias. So this means basically that sometimes expert collected samples were higher in concentration than homeowner collected samples, and then kind of vice versa. So we kind of found that this inconsistent bias leads us to the question if whether what is contributing to this bias and whether or not system factors are contributing, which I think Leanne will talk a little bit more about later, and some of the questions that we have there. So I'll hand it back over to her and she'll finish this out. Thanks.
Awesome. Okay, so as Kathleen said, any good research leaves you with more questions, right? So we're moving into our phase 2, and I'm delighted to report that despite EPA's surprise birthday gift, I've gotten Kathleen to agree to stay and work on her PhD with me on this. We're expanding now to do our sampling in 6 different counties, and we picked these to be in 3 different geographic regions and also to be representative of those original VDH high and low risk. So we're doing this in these 3 geologic regions. We're developing public education and communication materials. That is really difficult in the face of evolving regulations. It's especially difficult because people are starting to hear more about PFAS. We also got some funding from USDA NEFA, working with Dr. Kong Zia, who's at the College of Ag with us, and runs the GC LCMS. Do I have all the letters right? There's so many alphabet soup when it comes to PFAS. I kind of mix them up. We're going to be doing a small pilot testing in Montgomery County. That's just because it's next to Virginia Tech, and we'll expand that to other counties in the state. And we're looking at doing some methods development. I mentioned earlier that at one point, there were actual standards at parts per quadrillion. So just to give you an idea of how small parts per trillion are, 1 part per trillion is equal to 1 drop in 20 Olympic swimming pools. This is according to the Michigan Department of Environmental Quality. I have a swimmer in my research group now, and being engineers, then we got into a big debate over whether there is a standard Olympic-sized swimming pool and what exactly the volume would be, and there were many meters per cubed and calculations happening before I said it's really small. 1 drop in any pool is really small. We have found as regulations evolve, and also, frankly, over the pandemic, we had different standards and supplies available. We have a little bit of waiver in what we're able to detect, and we're trying to shore that up before we start doing more broader testing. We're actually thinking about partnering with some Virginia Household Water Quality Program affiliates in other states, and we want to really make sure we've got our methods correct. Now, Kathleen mentioned that we saw this inconsistent bias. So we had homeowners collect 2 point-of-use samples, and our experts collected 1. On average, we had 1 sample was a little higher than the expert and 1 was a little lower. So we were thinking that if there was a problem with sampling, we would see For example, if homeowners armed with gloves could not follow our instructions and were putting on mascara and then rubbing the bottles or goodness knows what, that we would see a consistent bias. And we didn't see that, which we think is due to the time of sampling. Kathleen typically went around midday or in the evening. That's when homeowners were available. Whereas to get that first draw lead sample, homeowners were collecting at the beginning part of the morning. So we think that this kind of shift in PFAS concentration might be related to time. So this may be analogous to what we've seen with lead, and it's coming from inside the house, right? So when you think about this, with lead leaches from solder and pipes. We're now going to do a study where we're going to do some PFAS profiling, and people are going to take water samples throughout the day. That's because we want to get water that represents the plumbing fixture right at the point of use, down into the main home, right? As you're collecting, each one represents a different part of the system, all the way down to the pressure tank, and then into the source water and the well itself. We've done some preliminary work with homeowners and found that lots of in-home plumbing includes Teflon tape and paste. If you remember, Teflon has PFAS. At one point, we were all supposed to be throwing away our Teflon cookware. If it's in your plumbing, it's very possible that it's leaching out. So again, kind of like lead solder. So this is our next project. And we're happy to take any questions. Hope I didn't ruin your day by telling you about PFAS. Knowledge is power. Thank you. All right, are there any questions?
I wonder if you've done anything to relate the water source to the geological source of the water, whether it differs between the aquifers, and I don't know how easy that is with the rock aquifers or not.
No, that's a really good question. We have not. We picked Floyd and Roanoke to start in because they have very similar base geologies, but of course we don't know which particular aquifer they're in. When we get our broader sample and we're across the 3 geologic regions, we are going to do some mapping and work with USGS, particularly on the Eastern Shore because of the drama there right now with PFAS, to see if we can get a little more close. We are collecting depth of well as far as the homeowner knows, but sometimes that's a big unknown as well. So, you can have a well, 2 wells very close to each other, but one is drilled much farther down. Groundwater just gets tricky. But that, once we have a broader sample, so it's less kind of niche house to house, that's something we're definitely going to look at. Yeah.
So for sample collection, did you let the water run for a certain amount of time before collecting it, or straight from the tap turn on?
So the standard practice for the typical cooperative extension, which is what they followed, is that they get a first draw sample, and then they let it run, and then they get, and this is mostly for metals, right? So we did the same thing for PFAS. They would collect, turn on the tap right away, collect their metals sample, collect their PFAS sample, let it run for a few minutes, and then collect the other samples. So we got both a kind of first draw and a flush. When Kathleen went, she just went and turned on the tap. And so we were kind of trying, and it does get at, are we trying to get at what's in the plumbing versus typical household exposure? So that's where we're at now, and what it seemed to tell us is that we need to go through and actually profile and see if there are changes. Yeah.
Any other questions?
Looks like you have one in the back.
Yeah.
Not to send her away. Sorry.
Are you going to do any controlled testing for the plumber's tape? Because there's very limited research on that.
Yes, so that is something that we just have a new student who's working with Dr. Zia and Kathleen named Ava, and we're going, this analogy to lead, there's standard testing with NSF, which is not National Science Foundation, but national standards, for how we do lead leaching. And we're going to repeat those studies, but for Teflon tape and Teflon paste. We're still actually trying to figure out the tape. We can cut a specific amount. With the paste, we're trying to figure out with surface area and what would be most kind of typical. Yeah, and then change our water chemistries to see what leaches. Yeah.
But are you going to do any in-situ testing where you put two pieces of pipe together and look at it?
Yeah.
Separately.
Exactly. No, exactly. So we're going to have to do just testing. We had a big meeting about this. Just testing the tape, right, per the standard, like you would test little pieces of lead plumbing, and then having it actually connecting PVC pipe, connecting more brass fittings. We have to pick different ones because there's also some evidence that PFAS can leach from PVC. So you're totally right. Plumbing is super complicated, and there are about 1 million different materials and fittings in any house. So every house is different. It's also expensive. We don't want to tell anyone to completely replumb their house.
All right. Well, thank you very much, Leanne and Kathleen.
Thanks.